In this video, we're talking about complex numbers. Before we get into complex numbers, we have to talk about what an imaginary number is. Now, up to this point in math, every time we see a square root that has a negative number underneath, we just would say this doesn't exist. We don't really have an answer for this. However, mathematicians said, you know what? Let's just make up something. Let's just say that there is an answer to this right here. And let's say that the answer to this is 2i. You might ask, well, what's I? Well, I is equal to the square root of -1. This right here is the definition of basically the bedrock, the foundation for what an imaginary number is. So an imaginary number looks like this, 2i, where that I is equal to the square root of -1. For example, if I ask you what's the square root of -25, well, we know that the square root of -25 is equal to the square root of 25 times -1, which is equal to square root of 25 times the square root of -1, which is equal to 5 times I. Okay? Now, from imaginary numbers, we go to complex numbers, and complex numbers include imaginary numbers. A complex number is any number of the form a plus bi, where a and b in this case are just real numbers. Think like 1, 2, 4.2, and I is equal to the square root of -1, right? Which is what we just saw up here. Okay? If you have a number, so for example, a complex number would be written like 2 plus 3i. If it were just 3i, this is just an imaginary number. But it's also a complex number. It would just be that number is 0 plus 3i. Okay? All right, so there's two parts to an imaginary complex number. Excuse me. The first part is the real part. In the real part, if I have this complex number, a plus b, the real part is a. A is always the real part. And you can sometimes see it written as RE, stands for real, right, of z. And z is z is commonly used to express as some complex number. Okay? And it's often we use a and b there to represent the two parts. So then the second part is the imaginary part. And that's expressed im for imaginary of z. Okay? And that's b. And notice the real part is a. So if you look at this example here, z, which stands for our complex number, is equal to 2 plus 3i. Then the real part is 2, and the imaginary part is 3. Another example, if z is equal to, complex number is equal to -√2i, the real part, even though there's nothing here, well, the nothing is 0, and the imaginary part is -√2. The complex conjugate, it's important. If we have some complex number z, where it's a plus bi, the complex conjugate is often expressed as z with a little star above it. Z like this, a little asterisk above it. And the complex conjugate is equal to a minus bi, given that this is z. All right? Here's an example right here, 2 plus 3i, the complex conjugate is 2 minus 3i. All right, so let's look at this example here. We want to write in terms of I, square root of negative 81. Well, I know that I can just rewrite that as 81, square root of 81 times square root of negative 1, and that's equal to 9i. Negative and b, negative times negative root 3. Well, I'm just going to keep the negative on the outside here. And then negative root 3 can be written like such. And so it's going to be a negative I times root 3 for an answer. Now let's say we wanted to solve quadratic equations. And this is where this comes in handy. Because usually we would get to this point where we would take the square root of both sides, and you'd end up right here. And you'd be like, well, I can't do anything. So back then, you used to be like, well, there's no real solutions. And that is true. There is no real solutions, but now there is imaginary solutions. So now when we get to this point, we don't stop. We say, okay, well, the square root of negative 4 is just x is plus or minus 2i. The same thing you can see here in b here. If I use the quadratic formula, you get to this point right here, negative root 7, and we just saw that if I had just previously in the quadratics, that if I had a number that's a negative, I would again say, oh, I have no real solutions. But now what we're saying is, the solution does exist. The final solution is a complex number. Okay? And that's all we will learn today, or that's all we'll intro with for complex numbers.